Today we'll be covering pages 8 and 9 of our Chapter 8 notes packet. So starting on page 8, you want to have your graphing calculator available while working through the problems on this video. Solving exponential equations. Using logarithms, find x to the nearest tenth. We have the equation 2 to the x equals 25. Now in last chapter, when our variable was in the exponent, we would try to get same bases. Well, we can see here that we cannot express 25 as 2 to a power. So we use logarithms. Now recall, 2 is our base, x is our exponent, and 25 is our answer. So what we want to do, this is an exponential form. We want to switch this to log form. Remember, log base. Or another way of writing it, if I want to write it with the exponent first, so kind of looking at this backwards, we would have the exponent is equal to log base b of our answer. So that's what we're going to do here, all right? We want to get x. So let's switch from exponential form to log form. So our exponent x is equal to log base 2 of our answer 25. Now we go to our calculator, log base, so this is alpha window number 5. So x equals log base 2 of 25, and rounding to nearest tenth, that's 4.6. Number 2, 5x plus, or excuse me, 5 to the x plus 30 equals 300. And we want to isolate our base with our exponent here. So we subtract 30 from both sides first. I'm not going to show that, but 300 subtract 30 is 270. And now we're in exponential form. The variable is in the exponent, so we'll switch to log form, right? So switch to log form. Go from exponential to log. So our exponent, x, is equal to log base 5 of 270. And to the calculator, alpha window number 5. Three-point rounding to nearest tenth. The 4 is in the tenths place. Look to the right. 5 or greater, you round up. So 3.5. Number 3. 2 times 2.1 to the x plus 4 equals 88. All right, we want to isolate this. We want to get our base with our variable exponent by itself. So the first step would be to subtract 4 from both sides. So 2 times 2.1 to the x is equal to 84. Divide both sides by 2. 2.1 to the x is equal to 42. We're in exponential form. Our base is 2.1, our exponent x, our answer 42. So we switch to log form. So that we'll have our exponent x is equal to log base 2.1 of 42. And the calculator. Alpha window number 5, log base 2.1 of 42. 5.0. Number 4, e to the 3x equals 48. This is exponential form. We switch it to log form. So our exponent 3x is equal to log base e of 48. But recall, log base e is the same as what? It's the same as ln. So log base e, I'll just replace it with ln. Now, we don't have x by itself just yet, so we divide both sides by 3. So x equals ln 48 divided by 3. and key this into the calculator as a fraction. So alpha y equals for my fraction, and ln 48 over 3. So ln 48, close parentheses, divided by 3. 1.3, that's going around to 1.3. Number 5. Okay, here's my base and exponent. We want to get this isolated, so we'll subtract 22 from 400. 2 times e to the 2x is equal to 378. Divide by 2. E to the 2x equals 378 divided by 2 is 189. Okay, here we are in exponential form. Switch to log form. So we'll have our exponent 2x is equal to log base e of 189. I'm going to move up here. I need to get x by itself before I touch the calculator. So I'm going to divide both sides by 2. And again, log base e is the same as ln. So I'll have x is equal to ln 189 divided by 2. Calculator. Alpha y equals for fraction. ln 189, close parentheses, divided by 2. 2.6, rounding to nearest tenths. Next, with number 6, here's x right here. Oh, okay. So it's not part of an exponent. So let's just get x by itself. Divide by 2. So x equals log base 5 of 219.6 divided by 2. And key that into the calculator. And I'll key it in as a fraction. So I need log base 5 of 219.6. So alpha window number 5, log base 5, 219.6. Close that. Nope, let's arrow out of that. Divided by 2. 1.675, that's going to round to 1.7. So utilizing a log key on our calculator there. Now, some word problems. Number 7, suppose you receive an inheritance of $5,000 and invest it at a 5% interest, compounded continuously. The equation is given to us. C of x is equal to 5,000 e to the 0.05x. This can be used to model this investment, where x is the number of years your money is invested. C of x represents the amount of money you have. How much money will you have in 6 years? All right, so we're taking our equation here, C of x is equal to 5,000 e to the 0.05x. So we're substituting 6 in for x. So we're actually finding the investment value after 6 years. So C of 6 is equal to, now just simply key this into the calculator as it is right there. 5,000 e to a power would be second ln, and we want 0.05 and then times 6. We're talking money, so let's round to nearest cent. $6,749.29. Second part, how long will it take for your money to double? Well, we want to round this to the nearest tenth of the year. Okay, so we're starting off with $5,000. So the end result for it to be doubled would be 10,000. So replace C of x with 10,000, meaning 10,000 is equal to 5,000 times e to the 0.05x. We need to solve this for x. Well, again, we must get this, our base and exponent here. We have to have that isolated first. So let's do that. We have 5,000 times that. Division undoes our multiplication, so we divide by 5,000. 10,000 divided by 5,000 is going to be 2. So 2 equals e to the 0.05x. This is exponential form. Our base is e, our exponent's 0.05x, and our answer is 2. So we switch to log form. So our exponent of 0.05x is equal to log base e of 2. Get x by itself, divide both sides by 0.05. So x is equal to log base e is the same as ln. Now if you don't recall that log base e is the same as ln, then it's perfectly fine that you key in log base e into the calculator. Okay, so to our calculator, alpha y equals ln of 2 divided by 0.05. And I want to round this to the nearest tenth of a year, so 13.86. This is going to round to 13.7. Or, excuse me, 13.9. So 13.9 years. And let me just show you again, if you don't recall that, if you ever forget the log base e is the same as ln, then alpha y equals, and then log base e, alpha window number 5, and we just put in e, which would be the second division to get e, so there's our base e, arrow out of that, of 2, and divided by 0.05. Next page. Now our next word problem, we have number 8. Jordan invests $7,500 at an annual rate of 4.5%, compounded continuously. According to the formula, A equals PE to the RT, where A is the amount, P is the principal, that's the initial amount, A being the ending amount. R is the rate of interest expressed as a decimal, and T is the time in years. Determine the amount of money you will have in 10 years. So in other words, we're taking our formula, A equals PE to the RT, making the substitutions. 7,500 is the investment, that's P. The rate is 4.5% as a decimal. Remember, take the decimal point, move it 2 places to the left. 0.045, and our time is 10 years. So A equals 7,500, e to the 0.045 times 10. Go to our calculator, 7,500, e to the 0.045 times 10. $11,762.34. Part B, determine how many years to nearest tenth it will take for the investment to triple. Well, to triple. So if we take the initial investment of $3,500 and multiply by 3, that's $22,500. So we're looking for an ending amount of $22,500. So $22,500 is our ending amount. That's our capital A value. Our initial value is still the $7,500. E to the interest rate is 0.045. And here we're finding the number of years. So we're finding T. So T is our variable we're solving for. Okay, so T is part of our exponent, so we want to get our base and our exponent here by itself. So get rid of the 7,500, divide by 7,500. Well, if we take the 22,500 and divide by 7,500, that's going to leave us with 3 equals e to the 0.045t. This is exponential form. Switch to log form. So our exponent 0.045t is equal to log base e of our answer 3. One more step. So we have t by itself, divide by 0.045. So t is equal to log base e is the same as ln. ln 3 divided by 0.045. And go to our calculator. Again, I'll key it in as a fraction. So alpha y equals, and then ln 3 over 0.045. 24 point, determine how many years to the nearest tenth, 24.4. Number 9, bacteria being grown for research programs at a college have a population modeled by the function b of t equals 1.25 t, or excuse me, 2 to the t, where b of t is in thousands of bacteria, and t represents the time in hours. After how many hours will the bacteria population reach 1 million? Round to the nearest hundredth of an hour. Round to the nearest hundredth. Okay. Now, this is given to us in thousands of bacteria. So 1 million. First, let's take our 1 million. 1 million is equivalent to how many thousands? Right? Well, if I just take off the 3 zeros here, so 1 million is equivalent to 1,000 thousands. 1 million is equivalent to 1,000 thousands. So we replace our b of t with 1,000, because 1 million is equivalent to 1,000 thousands. So 1,000 is equal to 1.25 times 2 to the t. And we're finding t, time here. So we need to isolate 2 to the t, so we divide both sides by 1.25. 2 to the t is equal to 1,000 divided by 1.25 is 800. This is exponential form. Our variable t is our exponent, so switch to log form. So our exponent t is equal to log base 2 of 800. Calculator. Alpha window number 5, log base 2 of 800 is 9.643, surrounding to nearest hundredth of an hour, 9.64. So 9.64 hours. Sorry about that. There we go. Okay, and our last word problem. The population of Gaston, Nevada is modeled by the function g of t is equal to 1,824 times 0.896 to the t, where t is a number of years since 1980. T is a number of years since 1980. In what year will the population be less than 50 people? Okay, so let's say, well, let's first find when it would equal 50. So replace g of t in our formula here with 50. So 50 equals 1,824 times 0.896 to the t. And we have to find the year. All right, again, let's isolate this. So we'll divide by 1,824. Okay, so I get this decimal. Okay, it's not a nice terminating decimal. Sorry about that glare. So let me just look at it. What is it as a fraction? So I'll just math frac it. Okay, so it's simply the fraction reduced 25 over 912. So I'm just going to reduce that to 25,912 equals 0.896 to the t. Okay. Now, exponential form, switch to log form. So our exponent t is equal to log base 0.896 of 25 over 912. Key this into the calculator just as it is. Right? Make sure, please, don't round anything. Keep that as a fraction. Don't use that decimal in any type of rounded form. Okay. So keying into the calculator. Alpha window number 5. So we have log base 0.896 of this fraction. Alpha y equals, for fraction, 25 over 912. 32.75. So t equals approximately 32.75. So about 32 3/4 years, they'll have 50. So let's boost that up to 33 years. It should be less than 50. All right, but it says in what year? In what year will the population be less than 50? So we want to take the 1980 and add 33 years to that. And that'll put us at 2013. So in the year 2013, it should have reached a population of less than 50. And this concludes our video for today.